video we are going to go over the bootstrapping for the confidence interval. We're going to use the population mean for this in SAS. So this is going to be proc t-tested. The data is equal to the data set. Alpha is equal to whatever alpha is. We have bootstrap slash n samples is equal to the most popular technique to do it would be using 1,000 samples. And any homework or test questions that you see involved in this will use 1,000 samples. You could change this to be 10,000 or so, but I highlighted it in bold, and we're just going to use 1,000 for this. And then boot CI is equal to BC. So we're going to use this to calculate the bootstrap confidence interval for the data set, the lead data set. So we're going to, using this data set here, we're going to use proc t-test. Data is equal to, I call this work.lead, and then alpha, I'm going to use an alpha of 5%. We're going to do this, the variable is going to be low lead level, otherwise it's going to do it for both variables I have in here. And then bootstrap slash n samples is equal to 1,000. Boot CI is equal to BC. And then run. And then eventually it's going to run this 1,000 times. It's going to take its sweet daily time into doing so. After all, 1,000 nowhere near a small number. But as you can see, I'll very slowly update the screen. And here we go. Okay. So it gives us the mean, standard deviation, standard error, so on and so forth. It gives us the confidence interval for the mean between 89 and 96, along with the 95% confidence level for the standard deviation as well. So it's both of these. The specific bootstrap ones are right down here. So the mean for this gives us a standard error for the bootstrap is 1.7592. Do note how that's different than the standard error that was inside of the actual data set compared to this one. This has a negative 0.0249 bias, and it gives us an updated confidence interval for the mean. Do note the difference between the actual and the bootstrap method. Likewise, the same thing for the standard deviation. It gives us the histogram and a box plot, so we could check to make sure that this is indeed approximately normal. And as you can see, as we highlight over it, gives us the different values. But as you can see, this is roughly normal. Again, it's slightly off. It also gives us the QQ plot here, so we could check to see if it's approximately normal. And it's pretty close to this line, right? Then it gives us the distribution of the bootstraps to show it approximately normal. This is for the low lead level group with 95% bootstrap bias corrected percentile interval. And it gives a second one for the standard deviation. This one's for the mean. This one's for the standard deviation. This is the QQ plot for the mean. Look how very close to that line that is. You could tell that by the fact that it looks pretty normal. And then the standard deviation one should be even closer, since that one was even more normal. And then this gives the correlation plot as well. Thank you.